Okay, we are learning about divisibility rules today, and this lesson is going to help you so much. It'll make your life so much easier if you could memorize these divisibility rules. It will save you so much time. This is really going to help you with what we're going to do for the rest of this week with greatest common factor and least common multiple, but it will really help you also when we get to algebra and beyond. I mean, if you can nail this, it will really save you so much time and headache for the rest of your math career, so to speak. So let's go through these divisibility rules real quick. Some of these you probably already know. For example, a number is divisible by 2 as long as the last digit is even. Okay, so divisible by 2, the rule is if the last digit is even. If you forget what that means that the last digit or the ones place has a 2, 4, 6, 8, or 0. In this example, since 724 ends in a 4, we know that it is divisible by 2 because 724 is even. A non-example here, 423, that's an odd number, so I know it's not divisible by 2. Okay, so that one you might already know. Another one you probably already know, I'm going to skip down here to the divisibility rule for 5. If the number ends with 5 or 0, then you know that number is divisible by 5. For example, 45 ends in a 5, so that means 45 is divisible by 5. 5 will go into 45 evenly. 92 doesn't end in a 0 or a 5, so I know 5 will not go into 92 evenly. And the last one you probably already know is the divisibility rule for 10. As long as the number ends in 0, then it's divisible by 10. So 7,200 ends in a 0, that is divisible by 10, whereas 4,258 ends in an 8, which is not a 0, therefore it's not divisible by 10. So those are the most common ones, 2, 5, and 10, but there are these other ones here that are super helpful. For example, the divisibility rule for 3. As long as the sum of the digits is divisible by 3, that means that entire number is divisible by 3. For example, the number 345. If I add those digits, 3 plus 4 plus 5, well, that is the same as 7 plus 5, which is 12. And 12 is divisible by 3. That means 345 is divisible by 3. Now, if I look at the non-example 317, if I add 3 plus 1, I get 4. 4 plus 7 is 11. And 11 is not divisible by 3, so that means 317 is not divisible by 3. So that's the divisibility rule for 3. That one is very similar to the divisibility rule for 9. Are you guys hearing this crazy thunder right now? This is a crazy storm. All right, so the divisibility rule for 9 is, again, if the sum of the digits is divisible by 9, then the number is divisible by 9. So 6,939. If I add 6 plus 9, I get 15, plus 3, 18, plus 9. 18 plus 9 is 27. And 27 is divisible by 9. I know that 9 times 3 gives me 27. So that means this number, 6,939, is divisible by 9. Whereas if I look at the non-example, 6,923, 6 plus 9 is 15, 15 plus 2 is 17, 17 plus 3 is 20. 20 is not divisible by 9, 9 is not a factor of 20, therefore 9 doesn't go into this big number, 6,923. So the rules for 3 and 9 are very similar. Let's talk, I know I'm skipping around a lot, hopefully you're following along. The divisibility rule for 6 is as long as the number is divisible by both 2 and 3, then it's divisible by 6. So if you know the rules for 2 and 3, you just test those out, and if the number satisfies both of them, then it's divisible by 6. So for example, 144, let's see, is that divisible by 2? Well, the rule says if the last digit is even. 4 is an even number, so I know 144 is divisible by 2. Now let's check the rule for 3. If I add the digits, 1 plus 4 is 5, 5 plus 4 is 9, 9 is divisible by 3, so that means this number passes the test for both 2 and 3, which means it's also divisible by 6. When I look at 517, doesn't end in an even number, so I know it's not divisible by 2, which means it's automatically not divisible by 6. So in order for a number to be divisible by 6, not only does it have to be even, but the sum of the digits also have to be divisible by 3. Okay, coming back up to the rule for 4. If the last 2 digits are divisible by 4, meaning if you look at the last 2 digits and that forms a number that's divisible by 4, that means the entire number is divisible by 4. So 712 ends in a 12. I know that 12 is divisible by 4. 3 times 4 is 12. So that means 712 is divisible by 4. 710, that ends in a 10. And 10 is not divisible by 4, so 710 is not divisible by 4. I should add to 4 if it ends in a double zero. So the rule for 4, if it ends in a double zero, then it's also divisible by 4. Like 100, 200, 300, 4,000. If there's 2 zeros on the end, then it's also divisible by 4. All right, that brings us to the rule for 8. Unfortunately, there's no rule for 7, at least not on this list. I think there's a complicated rule elsewhere. But the rule for 8 is if the last 3 digits are divisible by 8. So that one is very similar to the rule for 4. You may have to do a little math on that one, actually do the division for the 3 digits, which is a lot easier to do than it is for 4, 5, 6, 7 digits. 840, if I do that math over here, 840 divided by 8, I know that 8 goes into 8 once. I know that 8 doesn't go into 4. I'll put a 0 there, but 8 goes into 40 5 times. So 8 definitely goes into 840 evenly. So that means 8 goes into 3,840 evenly. And for the non-example, 6,428. So if I take 428, that looks like it might be divisible by 8 because it ends in an 8, but let's check here. So 8 doesn't go into 4, but it goes into 42 5 times, which is 40. And we subtract and we get 2. Bring down the 8. 8 goes into 28 3 times, which is 24. But there's a remainder. There's a remainder of 4, so it doesn't go in evenly. So that means that 6,428 is not divisible by 8. So those are all the divisibility rules. So let's now apply them on this IXL assignment. So first question on IXL C1, divisibility rules, is this ginormous number divisible by 10, 57,603,050. Is that divisible by 10? Please do not be alarmed when you see these huge numbers, because when you use these rules, they're really easy. For example, they're asking about if it's divisible by 10. The rule was if the number ends in 0, it's divisible by 10. This ends in a 0, so yes, that number is divisible by 10. Okay, this asking me for this huge number, 25,581,558. Is that divisible by 5? Well, it doesn't end in a 5 or a 0, so it's not divisible by 5. How do I check to see if 870,400 is divisible by 9? Look back at your rules. This is the one where I have to add up the digits. 8 plus 7 is 15, plus 0 is still 15, plus 4 is 19, and 19 is not divisible by 9, so there we have that one. Is this number divisible by 6? So the rule for 6, we have to check 2 and 3. It is even, so it checks off on 2. It needs to check off on 3 as well. And for 3, we have to add the digits. So 1 plus 4 is 5, plus 3 is 8, plus the 4 is 12. 12 is divisible by 3, so it checks off for both 2 and 3, which means that's a yes. Type a digit that makes this statement true. Then we want to make this big number divisible by 4. So the rule for 4 is if the last 2 digits are divisible by 4. They already put an 8 here, so let's think of a 2-digit number that is divisible by 4 that ends in an 8. How about 28? 28 is divisible by 4. 28 divided by 4 is 7. So if I just put a 2 here, then that makes this huge number divisible by 4. We want this number to be divisible by 5, so as long as it ends in a 0 or a 5, that'll work. And there you have it. That's C1. Now let's look at E4. Which numbers are factors of 20? So this is just practicing your knowledge of factors, and you can use the divisibility rules to help you. Does 6 go into 20? No. 10 goes into 20 twice. Does 3 go into 20? Wait, I'm not sure. So let me check my divisibility rules. 2 plus 0 is 2. 2 is not divisible by 3. So no, 3 isn't divisible, which means 9 isn't divisible, because if it's not divisible by 3, it's not divisible by 9. So there you have it. Besides 14 and 1, what is one factor of 14? So what's another number that goes into 14? Well, I know that it's even, so 2 goes into 14. So here I can use my divisibility rules again. All right, which number is a factor of 18? So it's even, so I know it's divisible by 2. Which number is a factor of 42? Again, it's even, So I know it's divisible by 2, which number is a factor of 78. Okay, so there's no 2 here, but there is a 6 here. So let's check if it's even. Let's also check if I add the digits, if I get a number divisible by 3. And 7 plus 8 is 15. 15 is divisible by 3. 15 divided by 3 is 5. Therefore, yes, 6 works. All right, so that's IXL E4. So please reach your goal scores on both of these exercises. Good luck. Use the divisibility rules to help you, and eventually you'll start to memorize them, and this will make your math life so much more easy breezy. Good luck.